Hello. I am going to be going through exam one from this semester, just as a review to help everyone study for the final exam. So, getting to it, number one, let's see. Identify if y equals 5x minus 2 is a function or not. Well, y is in terms of just x, so y is a function of x. So, we're okay there. Another definition for a function is if it passes the vertical line test. So 1b is x equals y squared plus 1, a function of x. Well, let's see. Let's try to solve for y to see if it is just in terms of x. So to solve for y, we get y squared equals x minus 1. Then we take the square root of both sides. Y equals plus or minus the square root of x minus 1. So because of the plus or minus there, this is not a function because it's not one-to-one. Basically, the plus or minus means it doesn't pass the vertical line test, because if we were to draw this, let's see, the square root of x minus 1, the minus 1, means it is a shift to the right 1 unit. So square root of x minus 1, and then the negative square root of x minus 1 looks like this. And then it does not pass the vertical line test. So not a function of x. For number 2, we're just doing the same thing but visually. Well, this one's easier. Vertical line test, not a function. Here, it passes the vertical line test. So it is a function. It's just a parabola. For problem 3, let's see, we're looking for the domain and interval notation. So remember, the domain of a rational function is we're just going to look at the denominator. So remember, we can't divide by 0. So we're going to solve the denominator, solve it equal to 0, and then see what x cannot be. So we're going to say x squared minus 9 equals 0, or x squared equals 9, or x equals plus or minus 3. So that means when x is positive 3 or negative 3, then the denominator is equal to 0, which we can't have. So basically we're going to take everything else. So that means negative infinity to negative 3, union with negative 3 to 3, and then 3 to infinity. Remember, these are all curved parentheses instead of square. Curved because we don't actually touch negative 3 or positive 3. Now, what's the domain of the square root of x minus 2? If it's an even root, then we have to have what's inside the function has to be greater than or equal to 0. So we said x minus 2 has to be greater than or equal to 0, which means x is greater than or equal to 2. So that's the interval 2 to infinity. This time we use the square bracket around 2 because x is greater than or equal to 2. Because you can take the square root of 0. The square root of 0 is just 0. And then here, it's the cubed root of x minus 4. So cubed root has no domain restrictions. Remember, the cubed root of x looks somewhat like this. This is the cubed root of x, where its domain is all real numbers. The square root of x is the one, or even roots of x have the domain restrictions. So for this one, we just say the domain is negative infinity to infinity. Okay, so problem 4. Let's see. Write the domain of the graphed function in interval notation. So remember, whenever there are open circles, that means the function is not included right there. So it looks like the domain goes from negative 5 to negative 3, negative 3 to negative 1, then negative 1 to 3. So let's see. And since these are filled in circles, we're going to use the bracket, so -5 to -3, unioned with -3. Sorry, just to make sure that this one is curved. Unioned with -3 to -1, unioned with -1 to 3. Now, if we notice here, since, well, actually, probably be better to circle it like this. The -1 has a square bracket and a curved bracket. So the square bracket means it's including the point, and the curved bracket means it's not including the point. But if we're including the point and have an interval where it's not including the point, we're still including the point. So we could write this as -5 to -3, unioned with -3 to +3. We can combine these two intervals right here. So either answer works. They both, mean the same thing. For part B, we want to write the range of the graph function in interval notation. So this time it's just the range. So the range are the y values. So the range, a lot of people are tempted to go from left to right still, but remember we want to go from the most negative to the most positive. So this is -2 to -1, and then 0 to 4. So let's see, -2 to -1, unioned with 0 to 4. And make sure to pay attention to the curved parentheses versus the square brackets, because we're not actually touching anything at y equals -2 or y equals -1, but we are at y equals 0. So then for part C, evaluate f of -1. So that is, what value does it take on when x equals -1? So here we have two options. One's an open circle, one's a closed circle. Open circle means it doesn't actually touch that point. Closed circle means it does. So here, f of -1 is actually just going to be 0. Oh, I guess there's a typo in this one. It says g, but we're asking f. So let's just turn this guy into a g and call it good. Awesome. Okay, so now even and odd functions, we want to classify whether these are even, odd, or neither. So for part A, we can do it just by looking at it. If it's a polynomial and all of the exponents are odd, then the function is odd. If all the exponents are even, then the function is even. Remember, if we have a constant term, so if this was 2x cubed minus x plus 5, the constant terms actually correspond to even exponents, because that's 5x to the 0th power, which is just 1. So be careful when you have constants there. So by looking at this, we see that 3 is odd, 1 is odd, so the function itself is odd. The other way you check is it's odd if f of -x equals -f of x, and even if f of -x equals f of x, and neither if, well, neither of these two things happen. So let's double check this. F of -x equals, let's see, equals 2 times -x cubed minus -x. Remember, -x cubed is -x cubed. So that negative can come out here, -2x cubed, and then -x is plus x, where this case equals -f of x. So we say it's odd. For part B, we can't really tell. It's rational. We can't really tell if it's even or odd. So we'll do the same thing. Let's see. I think I can artificially create more room by zooming in. So here I'll say f of negative x equals 2 negative x minus 1 over negative x plus 1. So that's negative 2x minus 1 over negative x plus 1. So if it were even, this would equal, if it were even, it would equal 2x minus 1 over x plus 1, which we can see it doesn't. So that's not true. If it were odd, it would equal negative f of x. So it would be negative 2x plus 1 over x plus 1, which we could also see that it doesn't. So if it's not even or odd, then it is neither. So either way, you just want to check if f of negative x equals negative f of x or f of negative x equals f of x. Okay, then problem 6 has to do with function composition. Let's see that f of x equal x squared and g of x equals x minus 2. Compute the following composite functions. Let's see, so f of g of x, log of x, I always like rewriting these to f of g of x, and that helps me just kind of visualize better what's happening. So we're basically taking g of x, the function g of x, and plugging it into the x for f of x. So g of x is right here. So that's f of x minus 2. And then we're taking this x minus 2 and plugging it into that x, which gives us x minus 2 squared. So just leave it like that, x minus 2 squared. Leaving it like this, I feel like gives us some more information anyways. If we look at this as a function, then it already tells us that, well, it's just squared tells us it's parabola, tells us that it's centered at, or the vertex is at 0, 2. So if we were to multiply this out, we just have to factor it again if we wanted to use it for anything. So I'm just going to leave the answer like this. Then part B is g of f of x. So that's g of f of x, where f of x is x squared, and g of x is x minus 2. So x minus 2, where x squared, is just going to look like x squared minus 2. Okay, and then g of 2. So that's g of 2. So what happens when you plug in 2 into g of x? That's 2 minus 2, or g of 0. And then g of 0 is what happens when you plug in 0 for g of x. So that's, so that's 0 minus 2, or negative 2. So this one we're just plugging in 2 to g of x, get 0, plug 0 into g of x, get negative 2. Okay, so for number 7, we're given two functions for a and b. Let's see. The graph of two functions are shown. Find their inverses if possible, or right does not exist for anyone that has no inverse. So first off, we have this parabolic function, x squared minus 2x plus 3, which is graphed above. And what we notice is that it doesn't pass the horizontal line test. Doesn't pass the horizontal line test. Therefore, the inverse does not exist. Has to pass the horizontal line test for a function to have an inverse. So we don't have to do anything else there, just say does not exist. And for function b, which is g of x equals x plus 3 over 4 minus x, well, it looks like it does pass the horizontal line test. So we're going to find the inverse there. Now, remember how we find the inverse of a function? Well, to find inverse, you're going to swap, swap x and y, then solve for y again. So instead of g of x, we're going to write y equals x plus 3 over 4 minus x. So when we swap it, we're going to say x equals y plus 3 over 4 minus y. Okay, and now I'm going to solve for y again. So first off, let's multiply both sides by 4 minus y. That gives us, let's see, if we distribute this over here, that gives us 4x minus xy equals, no, cancel off from the right hand side, y plus 3. So we're going to get everything with a y on one side, everything else on the other side. So I'm going to subtract y from both sides and subtract 4x from both sides, giving us negative y minus xy equals negative 4x plus 3. Okay, now I still want to have just y on the left-hand side, so I'm going to factor out a y and then divide by what's left over. So if I factor out a y, this is y times negative 1 minus x. And then I'm going to divide both sides by negative 1 minus x. So this gives us y equals negative 4x plus 3 over negative 1 minus x. We can also simplify this a little bit. I don't like how many negatives are in there, so if we multiply it by negative 1 over negative 1, just multiplying it by 1, so negatives cancel out, we get 4x minus 3 over, I'm going to write it x plus 1. So here, 4x minus 3 over x plus 1 is the inverse of g of x. Now, I'm not going to do it right now, but remember you can always double check if something is an inverse, because if you do function composition, if g of g inverse, I could write that a little bit better, g inverse of x equals x, and g inverse of g of x should equal x. So those are two ways to double check it. Now let's go on to problem 8. So for the function of x equals x plus 2 times x minus 1 squared, we want to find the y-intercept. So the best way to find the y-intercept is to plug in 0 for x. So f of 0 equals, let's see, 2 times negative 1 squared, or just 2, since negative 1 squared is positive 1. So the y-intercept is 0, 2. Now to find the x-intercept, usually it's a little bit more work, not too much. Instead of plugging in 0 for x, we set the entire thing equal to 0. Equals 0. So this tells us that whatever x's make this function equal to 0 is an x-intercept. Since it's already usually we would factor it, but since it's already in factored form, we can say that to set x plus 2 equal to 0 tells us that x equals negative 2. And then to set x minus 1 squared equals 0 tells us that x equals 1 with multiplicity 2. So the x-intercepts are, let's see, negative 2, 0, and 1, 0. Okay, then for part C, we just sketch a graph of this showing the intercepts with multiplicity and end behavior. So the x-intercepts are negative 2, 0, and 1, 0. We have the y-intercept is at 0, 2. Okay, now we want to find out what the end behavior is, and what the, and what it looks like in between. So I like to do a sign line for this. So I'm going to put in all of the intercepts. So let's see, the intercepts are, let's see, negative 2 and 1. So if x is greater than 1 in this function, then let's see. Yeah, so if x is greater than 1 here, say x is 50, plug in 50 into this function, we get 50 plus 2 is positive, and then 49 squared is also positive. So it's going to be positive right here. Then if we want to use the multiplicity argument to find the other intervals, let's see, where x equals 1, we remember that it has a multiplicity of 2. So if it has even multiplicity, the sign is going to stay the same. And if it has odd multiplicity, the sign is going to change. So at x equals negative 2, the multiplicity is, we didn't write it down, so it must be 1. So it's going to change. So here, we know that it's going to, the end behavior is going to be positive. Down here, it's going to be negative. So let's just connect the dots, going down to here. Also, since it is an even multiplicity, we're going to bounce, which makes sense because we want to go through this intercept. And then we're just going to keep following through to the other end behavior, which makes sense. It's what we want. We do this a lot more involved with rational functions. So hopefully we remember how to do this for the most part. Okay, so problem 9 is quadratic functions. Let's see, put the function f of x equals x squared minus 4x plus 5 into vertex form. So let's see. To do this, we want to complete the square. So f of x equals x squared minus 4x plus and minus. So I'm going to add and subtract the same number, because adding and subtracting the same number is the same thing as adding by 0, which doesn't change the function at all. So what we're going to add and subtract is going to be b divided by 2 squared. So in this case, b is negative 4. So negative 4 divided by 2 is negative 2. Negative 2 squared is 4. So I'm going to add 4, subtract 4. And now, by what we've done, everything on the inside makes a perfect square. So the perfect square is always going to be x minus b over 2 squared. And then whatever's left over, negative 4 plus 5 is plus 1. So this is x minus negative 2. So x plus 2 squared plus 1. Sorry, that should be a minus 2. X minus 2 squared plus 1. So that's going to be our vertex form. F of x equals x minus 2 squared plus 1. And now for part B, we want to find which graph this is. So it's squared, so we know it's a parabola. These all look like parabolas. The plus 1 on the outside corresponds to a vertical shift, so we're shifting up 1. The minus 2 on the inside, remember when it's on the inside of the function, we're doing the opposite, so it's going to be a shift to the right 2. So if we look at C, we're shifting 2 to the right and 1 up. So that's what our function is. That's the graph of our function. And then lastly, we want to write the equation of a function, f of x, that has the graph shown below. So normally we're given a function and we want to graph it. Here we're given a graph. We want to write down what a possible function could be. In general, there are multiple answers, but if we just go for the most simple one, then we're usually a bit happier if we try to find the most complicated one. So the first step is to look at the intercepts. So we have x equals -2 with multiplicity 2 and 1 with multiplicity 2. And the y-intercept is the point 0, -4. Okay, so we're going to put this together as our guess. So our guess is going to be f of x equals a times x plus 2 squared times x minus 1 squared. So the x plus 2 comes here, the multiplicity is 2. The 1 goes here, and the multiplicity is also 2. And the a is because we don't know what the vertical scaling is. So we want to make sure that we have an a there so we can make sure it hits the right y-intercept. So we have the y-intercept of 0, 4. So that means that f of 0 equals -4. So let's make sure that's true. F of 0 equals a 2 squared, -1 squared, which -1 squared is 1, 2 squared is 4. So that's 4a equals -4. So we want to choose a, or solve for a, so that this is true. So here we just divide both sides by 4, so a equals -1. So our final answer will be negative x plus 2 squared x minus 1 squared. All right, and that is exam 1. And yeah, I'll see you next time.